Now let's talk about logical values. Notice how logical values are defined with capital letters that say true or false. That's it. Logical values can either be true or false. So now I'm creating a vector of logical values. The class of that vector is logical, and the type of data contained in that vector is logical. Here's a vector of characters. Notice the quotes and the letters are contained within the quotes. It's a big difference whether you have quotes or no quotes. If I had here the letter E without quotes, R would expect that I had previously named an object E, and it would give me an error message that the object is not found. But when I have it in quotes, it assumes that I want to use it as a character, and so therefore it's going to create a character vector. Let's take a look at the class is character, and the type of data in our vector is character. So because the class is character, only functions that operate on letters will actually be able to operate on this particular vector. So we've now had a numeric or double vector. We have an integer vector. Remember, both types are numeric, except that integer is a special case where you're not going to have decimal points. We have characters and we have logical. What if you have multiple characters between quotes? These are called strings. So notice here now, for our course 2, I created EDRM within quotes, and I created 718 within quotes. If you look here at our course 2, it's a character, but it only has 2 elements. Not as many elements as there are number of letters, but rather 2 elements because it's 2 strings within those quotes. EDRM is the first one, 718 is the second. So a string is one or more characters. That means that characters are strings. However, R does not call a vector of strings a string vector. It calls it a character vector. When I look at the class, I have the wrong name on this. Sorry. Still have the wrong name. This is good for you to see because you might have worried that if I were to get an error like that, that it might blow up my computer, and you can see it didn't. It just gave me an error message in a different color. All right, so we have character for our course 2, and type of data is character. Now let's talk about what happens when we mix data types and try to create a vector. R is always going to create an atomic vector, even when you mix data types. Wait a minute, you say. You said that atomic vectors were all the same data type. Yes, I did indeed. And that's what's going to happen with the vectors we create in R with different data types. They're all going to be changed to the same data type. So when I create this vector here that has an integer, a double, and a double, that's actually going to perform an operation called implicit coercion. That sounds pretty nasty. R can be nasty when it needs to be. It can strong-arm this data, and it's going to strong-arm the data. It is going to take and change one or the other of these. Well, which one's it going to change? Let's see. So I put this in different types. Let's see what class we now have. We have numeric. We don't have integer. We have numeric, which is what it told us the class would be for anything numeric. That is, if you have data that are numeric, it doesn't matter if they're integer or not, functions that can work with decimals will be able to work with them. And so this was all coerced to numeric. The way you can think of it is when there's two different types of data, lower level data are changed to upper level data. That is, you can change a 2 to a double, for instance, 2.0. But you can't change a 6.2 to an integer not without doing something else like rounding. So we really don't lose anything when we change the integer 2 to a double 2, but we would lose something if we change the 6.2 to an integer 6. So data at lower levels are changed to a higher level. If we look at the type, we now have double data. So that means that the 2 and the 4 integers are doubles. Let's look at this one. We have logicals, true, true, false, and we have characters, EDRM 718. Let's see what happens. This is changed to a character. And so now we have in our data, if I were to look at that one, I call that what, different types 2. Notice what happened. The logical true is no longer a logical true. It's now changed to true in quotation marks. So therefore, it's a character. You can't use that to represent true or false anymore. You're now using it for the word true. So the class of different types 2 is character, and the type of is character. Here's one interesting one. Here I have true, true, false, and then 2 integers, 2 and a 4. Let's see what happens. It changed them to an integer, and the type is integer. Well, if I look at different types 3, notice something that's going to be important to us when we write scripts. True takes on the integer value of 1. False takes on the integer value of 0. And then finally, we have a logical, an integer, a double, and a character. What happens here? It changed them to class character, and the type of data is character. If I type in different types 4, I'll see that all of these are characters. Now, if you think about it, there's a general principle going on here. Take different types 4. How would you change the string EDRM to a number? I don't know. How would you change 4 to a character? Yeah, put it in quotes, make it a character. So what's being done is R is taking data at a lower level, that is, something that could be changed higher up to that higher up, as opposed to something that can't be changed to lower levels. So a nice way to think of it is maybe categorical and quantitative data. You can change quantitative data to categories, but you can't change categories to quantitative data. You could change data like 1, 2, 3 to 3 different levels of socioeconomic status, the 1, 2, 3. But if you had 3 levels of socioeconomic status, low, middle, and high, how are you going to change those to numbers other than to make them numerals to represent something? So the lower levels are changed to the upper levels. Look back here at this list. I have them in order. Logical is lowest, so it can be changed to an integer. Integer is next, so logical and integer can both be changed to doubles. Logical, integer, and double can all be changed to character, but none of these can be done the other way around. So that's what happens with implicit coercion.